All right, welcome back. So we've already covered where our body fluid is and how it moves between compartments. But today we get to the really cool part. How does our body actually control all of it? Let's dive into the hormonal systems that are the true managers of our internal fluid world. You know that feeling, right? That bone dry, almost desperate need for a glass of water after you've been outside all day? Yeah, that is not a random feeling. Nope, that is a highly specific, very urgent message coming straight from your body's control room. It's your brain acting as this incredible command center, constantly monitoring your internal state to keep everything perfectly in balance. So who are these controllers sending the messages? Well, they're hormones. These are the chemical messengers working tirelessly, 24/7, completely behind the scenes to keep you stable. And what's their mission? It's a huge juggling act. They're constantly tweaking how much water your kidneys reabsorb, managing the delicate balance of sodium and potassium, and controlling your blood pressure and overall blood volume. I mean, it is a seriously high-stakes job. So let's meet the two big systems that are basically the body's first responders. When your fluid levels are off or your blood gets too concentrated, these guys are called into action. They are the masters of conservation. First up is antidiuretic hormone, or ADH. A great way to think of ADH is as the body's water warden. Its mission is simple and direct. If dehydration is even a remote threat, it will lock down the water supply and reabsorb as much as possible. No questions asked. So what calls the water warden into action? Well, your brain's sensors are unbelievably sensitive. If your blood gets just 1 to 2% more concentrated, that's enough to trigger ADH release. A big drop in blood pressure or blood volume will do it too, along with a few other distress signals. And how it works is just fascinating. ADH travels to the kidneys, and there it literally inserts these tiny, specialized water channels called aquaporins into the kidney's plumbing. It's like opening up a series of gates that allows water to rush back into the body, leaving what's left behind, the urine, much more concentrated. Okay, our second major system is the Renin, angiotensin, aldosterone system, or RAAS for short. If ADH is the water warden, then think of RAAS as the pressure and salt commander. It's not just one hormone, it's a powerful, multi-step chain reaction designed to defend your blood pressure and sodium levels with absolute precision. So let's walk through this cascade. It all starts in the kidneys. When they sense that pressure is low, they release an enzyme called renin. Renin then finds a protein made by the liver and converts it into something called angiotensin 1. But we're not done. As that blood passes through the lungs, another enzyme called ACE converts it into its final super potent form, angiotensin 2. And angiotensin 2 is the real power player. It's an incredible multitasker. It squeezes blood vessels to raise your blood pressure immediately. It tells your adrenal glands to release another hormone, aldosterone. It triggers ADH, our water warden, to start saving water. And it directly stimulates the thirst center in your brain. It's a full-scale, all-out defense. So aldosterone gets the final order from angiotensin 2. Its specific job is to tell the kidneys to reabsorb sodium but secrete potassium. And here's one of the most fundamental rules in physiology. Where sodium goes, water follows. So by saving sodium, the body automatically saves water too. It's a brilliant 2-for-1 deal to raise your blood volume. Now get this, 2%. It doesn't sound like much, does it? But aldosterone reabsorbs about 2% of all the sodium filtered by your kidneys. And that tiny 2% is actually equivalent to the entire amount of sodium in all of your blood plasma. It's a perfect example of how a tiny percentage can have a massive, massive effect. Okay, so we have these incredibly powerful systems to raise blood pressure and save water. But what happens if they go too far? The body absolutely needs a safety valve, a counterbalance, to prevent overload. And it has one. Meet Atrial natriuretic peptide, or ANP. This is the body's pressure relief valve. It's actually released by the muscle cells of your heart. When the atria, the top chambers, get stretched out by too much blood volume, they release ANP. It's the heart's way of sending out a signal saying, hey, we're under too much pressure, time to dial it back. This is the beautiful balancing act right here. It's a constant tug of war. On one side, you have RAAS and ADH working to retain salt and water, constrict blood vessels, and raise blood pressure. And on the other side, you have ANP doing the exact opposite. It promotes excretion of salt and water, dilates blood vessels, and actively inhibits the RAAS system. It's a perfect push and pull. So this really isn't a story about one system winning.
It's this dynamic, constant process, with your body making real-time adjustments every single second to keep you in that perfect physiological sweet spot. And this table just sums it all up perfectly. If your blood volume is low, boom, RAAS and ADH ramp up and you feel thirsty. If your blood volume is too high, ANP steps in and shuts those other systems down. If your blood is just too concentrated, ADH and thirst are the primary response. It's such an elegant, integrated network.
But what happens when this perfectly tuned system breaks? Understanding these hormones isn't just an academic exercise. It is absolutely essential to understanding the why behind many common and very serious diseases.
Just look at this number, 20 liters. That can be the daily urine output for a person with a condition called diabetes insipidus. This is where ADH, the water warden, is missing. Without it, the kidneys just can't open those water channels, leading to massive fluid loss and an unquenchable, overwhelming thirst. Now, the opposite problem is something called SIADH. This is when the body releases way too much ADH when it's not supposed to. The kidneys go into water retention overdrive. All that extra water dilutes the body's sodium to dangerously low levels, and that's a huge problem because our entire nervous system depends on that precise sodium balance to function.
And then there's heart failure, which is just a tragic irony. A weak heart can't pump blood effectively, so the kidneys sense low pressure. The kidneys can't tell the difference between low pressure from dehydration and low pressure from a failing heart. So they do what they're programmed to do. They crank up RAAS and ADH to try and help by increasing the volume. But that's the absolute worst thing to do. All that extra salt and water just overloads the failing heart even more, causing fluid backup and swelling. It's a vicious cycle where a life-saving system actually accelerates the disease.
So from a single hormone molecule all the way to life and death situations in a hospital, this really is an unseen symphony. It's this incredibly coordinated dance of chemical messengers that keeps our internal ocean perfectly balanced.
And that leaves us with a final thought. This entire complex system of sensors and messengers and responders works perfectly, billions of times a day, without you ever having to think about it. It just happens. And it makes you wonder, what other incredible symphonies are playing out inside of you right this very moment?